Hello everyone, Jen to all. Welcome in a digital studio of AKG. In this video lecture, I am going to discuss about stack. First of all, I want to give an outline of this video recording. The outline of this video recording is definition of stack, then types of stack, LDS, linear data structure and non-linear data structure. After that, type of stack. This is the type of data structure in which we have to discuss how the data is classified in different types. After that, the types of stack. Then application of stack as a ADT, object data type. Then basic operation on stack, representation of stack, algorithm, then array implementation of stack. In this topic, we have to discuss only about the array implementation. Stack is also implemented in different way, but here we have to discuss only about the array implementation of stack. The definition of stack is a linear data structure in which insertion and deletion are allowed only at one end, called top of the stack. This is the main point which is followed by the stack. First of all, we want to discuss what is meant by linear and what is meant by non-linear. Linear means if a data is stored in a contiguous memory location and there are only one previous node and one next node, then the data structure is called linear. Here, a stack is a linear data structure in which insertion and deletion are allowed only at one end, called top of the stack. We have to insert or delete element from the top. This is the simple structure of stack. This is the bottom place and this one is the top place. That means we have to insert from top and delete from top. If already there are two data A and B and we want to start a C, then C is inserted here. And if we want to delete an element, then we have to first delete C. That's why we called the top of the stack. The order may be called LIFO, last in, first out. This follow the property of LIFO, last in, first out, or FIFO, first in, last out. This both condition may be follow in the case of stack. Now, this is a simple structure of a stack in which this is the bottom symbol, this is the next to the bottom, and this is the top. If we want to pop means delete. Here we have used two terms. The first one is pop for delete and second one is push for insert. This is the same operation, but in case of stack, we have to use push as a insert and pop as a delete. And remaining operation is called as it is, in which we have to call in similar in a remaining data structure. But here in case of data structure, insertion is called as push operation and deletion is called as pop operation. If we want to insert this dice, we have to insert at the top of the stack, and if we want to delete, then this top stack is deleted by operation pop. The next one is linear data structure, which is discussed in the first slides. Linear data structure means the data is stored in a contiguous memory location. In a linear data structure, the data is also stored in the same level. There is no difference between level and there is no classification of level. All data lie on the same level and that is called a single level data structure. A linear data structure is a structure in which the elements are stored sequentially and the elements are connected to the previous and the next element. In linear data structure, single level is involved. There is no classification of level. All data is stored at the single level. And this is the non-linear data structure. A non-linear data structure is another type of data structure in which the data elements are stored or arranged in a contiguous manner. In a non-linear data structure, an element can be connected to more than two elements. In non-linear data structure, multiple levels are involved. There are mainly two differences. The first is the element store more than two levels. Are more than two for a given nodes, there are two previous node or more than one next node. But in case of linear data structure, for the given node, single previous node and single next node. Here we have also classified in multiple level are involved, but in case of linear data structure, single level is involved. This is the type of stack. First, we talk about register stack. In case of register stack, this type of stack is used to store a small amount of data in memory. If we want to store a list of 100 students or a list of 1000 students, then we have to use as a register stack. And basically, register stack is used to process the operating system data. That means if the predefined command inside the memory, then we have to execute that command by using register stack. The next one is memory stack. This one is the mainly used for arrange the memory or manage the memory. This type of stack is used to store large amount of data. The size is flexible, means used to store large amount of data. That means there is no limitation of size. We have to store the data as much as required. There is no limitation of the size of memory. But in case of register stack, there is a limitation of size of memory, and we have to use limited size, and we have to process the data by using these two registers. Now, this is the main topic of stack, that is the application of stack. In application of stack, we have to use for evaluating the value of expression. If I have a mathematical expression and we want to find the value of the given mathematical expression, then we used stack to evaluate the value of mathematical expression by using this stack. Second one is used for infix to postfix conversion. There are three types of expression: infix, postfix, and prefix. Infix means the operator in between the operand. Prefix means the operator before the operand, and postfix means the operator after the operand. And if we want to convert this infix expression into postfix, for this we have to use stack to convert infix expression into postfix. Next one is used for infix to prefix conversion. This is also used for infix to prefix conversion. That means for the any types of conversion which may be infix to prefix or which may be infix to postfix, we have to use stack to convert this type of expression to another type of expression. Next one is used for function call, that is called recursion. You have idea about recursion? Recursion means a function call itself is called recursion, and by using function call, we have to use stack to call the given function at a given time in a case of recursion. The next one is used for backtracking. This is the basic concept of traversing or processing of the data. Backtracking means we have to follow certain rule and regulations. After certain times, we decided for the given steps or following steps, the result is not displayed or the result is not shown. Then we have to backtrack and use another path to find the solution of the given question. That is called backtracking. For a particular step, we have to backtrack to previous step, and we have to find another path to find the solution of the given question. We have to use by this backtracking. Next one is used for reverse the string. That means we have to string A, B, B, C, C. We want to reverse this string by using stack. This is the main application of stack, which is used to reverse of any string. Used for matching text in HTML and XML. This is also used in hypertext markup language and extended markup language for matching the tag. And so that stack is the main heart of data structure. We have to already discuss in previous slide. This is the stack as a ADT. How we have to use stack as a ADT? When we define stack as a ADT or abstract data type, then we are only interested in knowing that the stack operation from the user point of view. We have not classified the operation, how the operation is work or how they are implemented. We have to only focus on what operation we have to call and what place we have to call these operations. means we are not interested in knowing the implementation detail. At this moment, we are only interested in knowing what type of operation we can perform on stack. We are not going to detail of the operation. We have only used to implement the particular operation in the given data structure. Now, the basic operation on stack, there are mainly 6 basic operation of stack. The first operation is push operation. As we saw in previous slide, push means insert. If we want to insert a new element, then we call push operation. Next one is pop. If we want to delete an element, then we have to use pop operation. Pick, return the top element of the stack. This is a function which is used to return the value of top variable in the stack. Is empty, this is the conditional statement which is used to check is the stack is empty or not. Next one is full. This is also a conditional statement which is used to check the stack is full or not. And last one is size. This gives the size of stack, which by calling the function we have returned by calling this size function, the data structure return the size of given stack, which may be in linked list form or which may be in stack form. Now, the next one is the representation of stack. Stacks may be represented in memory in various ways. Here we have discussed about mainly two ways. The first one is array representation. In case of array representation, we use one-dimensional array to represent the stack like this. This is the array. The name of the array is stack ARR, and this is the bottom, that means initial value, starting value, and this is the max of stack. In a previous case, we have discussed the insertion and deletion take place from top of the stack. Here, this place is called top of the stack. If we want to store the value of the given in the given array, then we have to insert at this place. And this is the maximum size. This is if we this place is also filled in, then this place is called top and maximum size also. But in this given case, this is the top value. That means if we want to insert a new element, then first we have to increment top with 1, top equal to top plus 1. Then we have to insert value at 4th position. This is the basic structure of data, how the data inside the memory is inserted or deleted in a given array. This is the link representation of stack. We use singly linked list to represent the stack. Singly linked list, here this is called head. Head is a pointer variable which points the very first node inside the list, and this one is the very first node is called top of the stack. That means if we want to insert an element in the given linked list, we have to insert here. First, we have to decrement top by top equal to top minus 1. Then we have to insert at this place. And deletion is also take place from this point. And this one is called bottom. As we know, in case of stack, there is no change in the bottom symbols. We have to only perform operation on top. It may be insertion or it may be deletion. We perform at top level so that we have to insert or delete element from this point. We can't insert or delete at this point. Now, we have discussed about the algorithm which is used to implement the stack. Here we have taken some variables. The operation is push. We have taken a variable stack, which is a stack data structure. Now the next variable is top, which contain the position of top element. Next one is max stack, which contain the maximum size of stack. And last one is item. This is the element which we want to insert in the given stack. Here we have given some explanation about the given stack. This procedure puts an item onto a stack. Now, step 1. Step 1 tells about stack is already filled. If we want to insert an element and there is no place inside the stack, then what we can do? We can't insert the element inside the stack. So that we have to first check each place is available inside the stack or not. For that, we have to using this condition. If top equal to max stack, then what we can do? Print overflow. If top equal to max stack, that means there is no place inside the stack, then what message to be print? Print overflow. Step 2, that means else. If this condition is false, then we have to go on step 2, set top equal to top plus 1. That means top is increment by 1. Step 3, set stack top equal to item. This is the item. If we want to insert an item inside the stack, then we have to insert here. First, we have to increment the top variable top equal to top plus 1. Then we have to insert top at the position top item. As we saw in a previous result, like this. I think this is a stack ABC. This is the top. And we want to insert a element C. Then first we have to increment top equal to top plus 1. We go on this place and we have to insert C at this place. This is the algo which gives the insertion operation for the stack. Now, this operation for pop operation. In pop operation, we have to take only stack pop item. This procedure pop the top element of the stack and assign it in the variable item. Here we have to take a variable item which hold the deleted items. In step 1, in case of delete, we have to first check is any element inside the stack or not. Then for this, we have to use stack has no item to be removed. If stack is already empty, at that condition, we can't do anything and we have to print underflow. In case of pop, the case is underflow, and in case of push, the case is overflow. Now, the step 2, set item is equal to stack top. We have to assign item in, we have to assign top value in item. And third one is set top equal to top minus 1. We have to decrement pointer by 1. Then we have to return the value which we want to set in the items. This is the algo for pop operations. Now, array implementation. Here we have to discuss a basic things which is used to represent the stack inside the memory by using array. We know that stack ARR is the array and insertion and deletion operation can perform at any place, but we want to stack array behave like a stack. For array to behave like a stack, we have to use some conditions. For that, we have to using some basic operations and rules for implementing this array. Hence, the insertion and deletion must be performed at one end. That one end is called top of the stack. For this, we keep a variable top which will keep track of the last inserted element or topmost element inside the array. This is the empty stack. There is no element inside the array and the top is also assigned with null value. But here for an array which have no value, we have to assign top with -1. This is the basic conditions which is used to show the stack is empty. This is the push for push operation. If we want to push an element in an empty array, then we have to increment top equal to top plus 1, and that top is incremented by 1. That means top equal to 0, and we have to insert the first value at location 0. If we want to next value, then we have to also increment top equal to top plus 1. That means the top goes content for 1 and the value is inserted at the position, first position. Like this, we have to insert all the coming element inside the array. This is the series of push and pop operation. Here we have to want to push element 1. We have to write like this. We want to push element 3 like this. By first, we have to top equal to top plus 1. Then we have to calculate the value of variable top and we have to insert the value at the particular location in the given array. By this, we have to inserting an element in a given array. This is the basic method which is used to insert the value. Like this, if we want to insert a 5, first we have to increment top equal to top plus 1, top equal to 1 plus 1, top equal to 2. We have to insert 5 at position 2. We want to insert push 7, top equal to top plus 1, top equal to 2 plus 1, then top equal to 3. We have to insert 7 at position 3. Like this, we have to insert all the coming element inside the stack or array. This is the next same conditions, we want to push 11, we want to push 12, we want to push 13. Like this, we have to insert the all element inside the stack. Note, this is the main point which we have to note here. Not possible, there is not enough space in the stack. This state called overflow. Here we have total 7 places in the array, and all 7 places is filled. Now we want to insert 13. We can't insert this 13 in the given array. This case arises overflow because we have no space. We have no space, so that this gives overflow conditions. Now the next operation is pop operation. By calling pop operation, we have to delete one by one element from the top of the stack. This is the operation which called pop. The first element is deleted pop, second element is deleted pop, third element is deleted. Like this, we have to delete all the element by calling one by one. Now the next part is the program which is used to calculate or create a array inside create a stack inside a main memory. This is the function stack. We are using array AR4. That means this is the size of the array or stack which is created inside the main memory, and this declaration is called global declaration. By using this global declaration, we have to create a stack inside the main memory. This is the main program which is used to create the array inside the main memory. This has defined max 4. That means we have to set the size of the array is 4, and by using these conditions, we have to push to 5, 6, 9, 13 and return 0. By using this code, we have to create a small array of size 4 in a main memory. This is the operation for pop. We top value and we want to delete element from the top of the stack. Then we have to run this code and we have to check if any condition for underflow or not. If the condition is not for underflow, then we have to execute the next part and we have to delete the element one by one in the given sequence. Thank you. This is all about the basic operation of stacks. If any doubts or any query, you can message in a comment box. Thank you. Thank you very much.